Hello friends, welcome back to my channel Engineering Mathematics DJ Ganit. In this lecture we are going to discuss this question about exponential distribution which was asked in GTU Winter 2020 exam for probability and statistics subject. The question is how exponential distribution is useful in real applications and find the mean and variance of the exponential distribution given in this way. We have already discussed 8 lectures about exponential distribution, and if you recall, we have defined PDF of exponential distribution using this formula: fx equal to lambda times e raised to minus lambda x, where x is positive and 0 elsewhere. If x is positive, then fx is non-negative and it is 0 elsewhere. Now here if you notice, here PDF is given in this form: 1 divided by beta e raised to minus x by beta. Instead of lambda, they are using 1 over beta. So in some references or some people define PDF of exponential distribution in this way also. So we can convert this PDF into our PDF which we have defined in terms of lambda simply by taking beta equal to 1 over lambda, or we can convert this PDF in terms of beta simply by replacing lambda by 1 over beta. If I consider lambda equal to 1 over beta here, I will have this form of PDF for exponential distribution. I am replacing lambda by 1 over beta and I have this PDF for exponential distribution, 0 elsewhere. So we must be familiar with both the form of PDF for exponential distribution. Some authors are using this PDF formula for exponential PDF. Some are using this PDF formula for exponential distribution. So as per the question, we have to decide whether we have to use this one or this one, and this is the relationship for converting this form into this form and vice versa. So here we are given PDF of exponential distribution in terms of parameter beta, and that we have understood that if we consider lambda equal to 1 over beta, we obtain this PDF, and both the PDFs are equivalent PDF for exponential distribution. And we are asked to find out mean and variance of exponential distribution whose PDF is given by this formula. Before that, we have to answer this question also: how exponential distribution is useful in real applications. So we have seen that if we are interested in the waiting time until some event occur, if we have this type of models, waiting time until some event occur or waiting time between two events, this type of situations can be modeled by exponential distribution. So they have asked this question: how exponential distribution is useful in real applications. So we can answer in writing in this way: exponential distribution occurs naturally when describing the waiting time until some event occurs. It can be used in many disciplines like queuing theory, physics, reliability theory, hydrology, and some insurance related theory, that is for queuing theory also. And I have written some examples of events that may be modeled by exponential distribution. For example, the time until a radioactive particle decays. So this is the model from physics. Similarly, the distance between road kills on a given road, this can also be modeled by exponential distribution. The distance between mutations on a DNA strand, the time it takes for a bank teller to serve a customer, the time between clicks of a geyser counter, the time until default on payment to company debt holders. So these are some events which can be or which may be modeled by exponential distribution. So for this question we can simply answer in this way, that exponential distribution can be modeled by this type of exponential distribution helps in modeling this type of events, and using exponential distribution we can solve the problems which can be modeled by that type of events. So this is the answer to the first sub part of the question. In the second part we are asked to find out mean and variance of this exponential distribution, whose PDF is given by this formula, and here we have to use the formula for mean of a random variable, that is expected value of x, and variance of x. We know that if capital X is a random variable whose PDF is given by fx, then mean of x is given by integral of x times fx from minus infinity to infinity, and variance is obtained by using this formula, expected value of x square minus square of expected value of x, that is mean of x, where this expected value of x square can be obtained by integrating x square times fx with respect to x from minus infinity to infinity. So first we will use this formula to obtain expected value of x, then we will obtain expected value of x square, and after using this formula we will be able to decide the variance for given exponential PDF. So I have again written this PDF of x is given by this, and first I try to find out expected value of a exponential random variable, mean of exponential random variable or exponential distribution, mean of exponential distribution is, notation is expected value of x, or we can use this also, this is equal to integral from minus infinity to infinity integral of x times fx dx. Now fx is 0 if x is different from positive real number. So this I can break into two integrals, integral from minus infinity to 0 because fx is different in both the intervals, and integral from 0 to infinity x times fx dx. If x is positive then only we have non-zero fx, otherwise it is 0. So here fx is 0, this integral becomes 0, and we have only integral from 0 to infinity x times value of fx if x is positive is 1 over beta e raised to minus x by beta. So that I substitute here 1 over beta e raised to minus x over beta dx. So this is simple problem of improper integral, and we can take this 1 over beta outside integral, and we have integral from 0 to infinity x times e raised to minus x over beta dx. To evaluate this improper integral, we can use the definition of improper integral. We can replace upper limit infinity by some finite real number b, and then we can consider limit for b tending to infinity. But we know that this integral is convergent because mean of random variable x, exponential random variable x is finite. So without using that limit definition, we can directly integrate this, and we can directly put x equal to 0 and x equal to infinity. And to integrate this, we will apply that formula integral by parts. If we have product of two functions, then this is given by u times integral of v, that is v1, minus derivative of u times integral of v1, that is v2, alternately positive negative signs, and derivative of first term and integral of second term, and so on. And we consider that function as u whose derivative is 0 after some finite number of steps. So here u is x and v is e raised to minus x over beta. So first we keep x as it is, integral of e raised to minus x over beta is e raised to minus x over beta divided by coefficient of x, which is minus 1 over beta, minus derivative of first term, that is derivative of x, into integral of this bracket again. So integral is again e raised to minus x over beta divided by minus 1 over beta into minus 1 over beta, that will become 1 over beta square. And in the next step, derivative of 1 will be 0, and limits are for x equal to 0 to infinity. Now we simplify or rewrite this before putting the limits. So we can rewrite this as this. I can rewrite as minus beta times x. We can take e raised to minus x over beta common, and here minus beta square, and we take e raised to minus x over beta common, which is common in both the terms. X is from 0 to infinity. So let me verify this. X into 1 over minus 1 over beta, that is minus beta x, minus 1 over beta square, that is beta square, and we take e raised to minus x over beta common. So here we are left with minus beta x, and here minus beta square. Now if we put upper limit as x tending to infinity, then if we concentrate on this part, then here I have minus infinity over beta if I take x equal to infinity here, but beta is positive, so minus infinity over beta is also infinity, and this will become 0. So if we take x tending to infinity, this will become 0. So we can put that for upper limit we obtain 0, minus for lower limit, if we take x equal to 0, then here we have 0 minus beta square, and e raised to 0 is 1. So for x equal to 0 we have 0 minus beta square, e raised to 0 is 1, and this is now 1 over beta times beta square, that turns out to be beta. So therefore expected value of x, or mean of exponential distribution, is beta, or we can simply write mu equal to beta. Now to find out variance, first I have to decide this expected value of x square, because variance of x is given by expected value of x square times square of expected value of x. We have obtained this. Now we try to obtain expected value of x square using this formula. So now in the next step, our aim is to decide expected value of x square. So let me choose another color. Here I find out expected value of x square, which is given by minus infinity to infinity x square times fx dx. Now fx is non-negative in 0 to infinity only, so here we can directly write this is equal to integral from 0 to infinity x square fx, because fx is positive if x is positive only, and it is 0 outside that interval. And now we put value of fx in the interval 0 to infinity, which is 1 over beta e raised to minus x over beta dx, and we can take 1 over beta again outside independent of x, and we have to integrate x square times e raised to minus x over beta with respect to x. Again we apply integration by parts. We take u equal to x square and v equal to e raised to minus x over beta. So this is now 1 over beta. Here x square as it is, integral of e raised to minus x over beta is e raised to minus x over beta divided by minus 1 over beta minus derivative of first bracket, which is 2x, times integral of second bracket, which is e raised to minus x over beta divided by minus 1 over beta, and there is already minus 1 over beta there, so we have 1 over beta square plus 2 times derivative of 2x is 2, integral of this again, so it is e raised to minus x over beta divided by 1 over beta square into minus 1 over beta. So in the denominator I will have minus 1 over beta to the power 3, and here I have e raised to minus x over beta. Limits are from x equal to 0 to x equal to infinity. And let me rewrite this by taking e raised to minus x over beta common, and I have minus beta times x square from the first term minus 2 beta square times x from the second term. Here also we have negative sign, minus 2 times beta to the power 3 into 1, and e raised to minus x over beta common. X is from 0 to infinity. Let me verify again. Minus beta x square minus 2 beta square x minus 2 beta raised to 3 e raised to minus x over beta common. Here also if we take x tending to infinity, because beta is positive, this will be 0. So for upper limit we have this times 0, that is 0, minus if we take x equal to 0, this becomes 0, this becomes 0, and we have minus 2 beta raised to 3 into e raised to 0, that is 1. So we are left with 2 times beta raised to 3, and that is nothing but 2 times beta square, because this will be 2 times beta raised to 3 divided by beta. Therefore what we have obtained is expected value of x square is 2 times beta square. Now we are able to find out variance of x. Variance of x is given by expected value of x square minus square of expected value of x. Expected value of x square is 2 beta square, and expected value of x is beta. So we have square of beta, that is going to be beta square, and we have variance equal to beta square. Therefore variance of exponential distribution is beta square and mean is beta. So finally we conclude that mean and variance of exponential distribution, mean and variance of exponential distribution are mu, that is mean is beta and variance is sigma square equal to beta square. Suppose we are given that another form of PDF in which our fx is defined as lambda times e raised to minus lambda x if x is positive, and 0 elsewhere. Then here lambda is nothing but 1 over beta, or beta is nothing but 1 over lambda. So for this PDF we can write down the mean and variance also. If we have that PDF, then mean is beta and variance is beta square. So here mean is beta and beta is 1 over lambda. So if we have fx in this form, mean will be equal to 1 over lambda. Similarly, variance in that form is beta square. So variance in this form will be 1 over lambda square. So there is nothing any problematic situation. If we are using this PDF, we will consider mean equal to 1 over lambda, variance equal to 1 over lambda square, and if we are using lambda equal to 1 over beta, then PDF will change and we will have mean equal to beta and variance equal to beta square. So you must be clear about this, both the PDF of gamma distribution. One PDF uses lambda times e raised to minus lambda x and 0 otherwise. This is the definition in terms of lambda which we have used up to lecture number 8. And if we consider the parameter beta, which is defined in this way, lambda equal to 1 over beta or beta equal to 1 over lambda, then this PDF can be rewritten as 1 over beta e raised to minus x over beta if x is positive and 0 elsewhere, and both are equivalent. We can convert this PDF or this PDF into one another by using this relationship. So you must be clear about both the relationships. So if you are asked to find out mean and variance of exponential distribution, and if you are given this PDF, then you have to use this PDF in this formula of mean and variance. Here I have taken fx equal to 1 over beta e raised to minus x over beta, and if I had used that formula fx equal to lambda into e raised to minus lambda x in this formula, then I would have obtained mu equal to 1 over lambda, and we know that 1 over lambda is nothing but beta. So we have obtained beta here because we are using beta instead of lambda in the PDF of exponential random variable. So this is all about this session. I hope you like it. Thanks for watching.